Hello guys and welcome back to our channel. So here we have a Toshiba laptop for repair and it doesn't turn on, so it's a no power case. So this is one of my friend's laptop. So he said that while he was working on the laptop, it suddenly went off and it didn't turn on thereafter. So based on the information, we can start from the main power rail, from the DC jack, then to the main power rail, then to the standby section and everywhere on the motherboard, and see what sections caused the laptop to turn off completely. Okay, so without making any delays, let's get in. Okay, now the display of the power supply is visible to you now, so let me connect the adapter. Okay, now the adapter is connected and you can see the ampere reading is around 3 milliamps. So let me open the laptop and try to press the power button here. Okay, now I'm pressing the power button and there's no response on the ampere reading. So there's no response to the power button here. So I think with this 3 milliamps there won't be any always voltages like 5 volt and 3 volt inductor voltages in this motherboard. So there might be the LDO voltages produced in this motherboard, but I'm not sure whether we have the coil voltages in this motherboard like 5 volt and 3 volt. So okay, so anyhow, let me open the laptop so that we can check the sections like standby and after that the entire motherboard. Okay. Okay, now the board is a little bit dusty, so we can just have a small clean around the area here. So with the paintbrush I can clean it. Okay, and the adapter is connected. And you can see still it is taking around 3 milliamps. Okay. So let me see what are the voltages in this motherboard. Let me see whether we have a main power rail in this motherboard. Okay. So where can we find a main power rail? So like this capacitor here, this filters the main power rail. So we can check on this capacitor, the ash color with the black cut on the edges here. Okay. So we can see there's no voltage, so we don't have a main power rail. So if I check on the DC connector here, and you can see we have the voltage. Yes, so the first and second MOSFET is not switching the voltage inside the motherboard here. Okay, so now we need to find where is the first and second MOSFET. Okay, so I think the first and second MOSFET is on the other side of the board. So I think we have to remove the board and take out the board so that we can have the first and second MOSFET. Okay, right, so let me take out the board. Okay, so now the board is out, so you can see on this side also we have some dust here, so I can just clean it off. Okay, now let me connect the adapter again. All right. So I guess this should be the first MOSFET. So you can see the trace coming in from this point, and here we have the positive wire and the negative wire. So positive end is on this point and the negative end is on this point. And you can see this is the fuse after the fuse, it comes into this inductor and it goes inside this MOSFET. So this is the drain side of the MOSFET and this is the source side of the MOSFET. You can see the marking, the dot, which shows the pin number 1. So pin number 1, 2 and 3 are the MOSFET and are the source, and the fourth pin is the gate, and the other rest of the 4 is the drain. As same here also we have the source, the gate and the drain. So this can be either P channel or N channel, or either one can be P channel and the other can be N channel. Sometimes you might see only one MOSFET and one diode. So in this case we have two MOSFET, but we need to find whether it is a P channel or N channel. Alright, and for the P channel we should have a gate lesser than the source, and for the N channel we should have a gate higher than the source. Okay, so we can find whether it is a P channel or N channel using the diode value. Okay, so now I am probing on the source side the positive probe, the other side the negative probe, so we can get a value. So you can see the value shows 400. So which means, so this is the source and this is the drain. So the arrow direction is towards this side. Okay, and we are getting a value as 400. And if I reverse the probe, I will get a higher value, which means now the diode direction is now reversed. So we are reading a value around 400 when we probe on this way. The positive probe on the source and negative probe on the drain. So when we probe on this way, so the value and the diode direction is towards this side. So from source to drain, it's an N-channel MOSFET. Okay, so let me check the other MOSFET here. Same direction. Yes, we do have 200. Okay. Yes. So on this side we have a value around, yeah, now we have 400. Okay. So this is also source to drain, so it's an N-channel MOSFET. So both of these are N-channel MOSFET. So for an N-channel MOSFET, we should have a higher gate with respect to source. Like in this case, we should have at least 24 volt on the gate pin in order for the N-channel MOSFET to switch voltages from drain to source and from here source to drain. Okay. Okay, so now let me connect the adapter and check the voltage on the gate pin of these MOSFETs so that we can have a clue. We don't have any voltage on the gate pin here, and here also we don't have. And let me see whether the gates are interconnected together with the MOSFET. Yes, so the gates are interconnected together. Okay, most probably this should be the charger IC on this side here, and you can see it is BQ25A. Okay, it's BQ25A. So we need to check the requirements why the charger IC is not releasing the 24 volt for the MOSFETs here. So the charger IC has an internal charge pump inside which boosts up the voltage by getting the 19 volt from its CM SRC pin, and it will boost up the voltage through its internal charge pump as a 24 volt for the gate of these MOSFETs here. So we should check whether the input voltage for the charger IC is okay, then the LDO output, which is the R region or VDDP. So if we have the R region, it is 6 volt, and if we have VDDP, it is 5 volt. So here we have the input resistor for the charger IC. We should check whether the input resistor for the charger IC is okay and the charger IC is having the LDO voltage correctly outputting it. Okay, so we need to check that as well. So connecting the adapter and checking the voltage on the charger IC. Okay, and we have 19.26, and on the other side we have 19.26. Okay, and if I check the resistance of the resistor there, and it shows 10.5, so that is fine. Okay, so let me check the LDO voltage from the charger IC. So maybe it should be 6 volt. No, from this side, no. 19 volt, this is the input voltage. Okay, no. So let me check it first. So what about this one? No. Yes, this is the RGN output. It's generating 6 volt here. Okay. So now we need to confirm why does the charger IC is not executing the AC drive voltage for these two MOSFETs. Okay. So for that we need to understand the working principle of the charger IC here. So we can go to the data sheet of the charger IC and have a look at it and then come back. Okay. Okay, so this is the charger IC in this motherboard. You can see it is BQ24725A. So this is the charger IC in this motherboard, and if you go down we can check its pinout details. Here we have the pinouts, and here we have the device information and overview of the charger IC. So you can see here we have the two N-channel MOSFET, same as in the motherboard. Because the arrow is pointing towards the gate, this arrow is also pointing towards the gate. So this is an N-channel MOSFET. These two are N-channel MOSFETs. So in order to drive the N-channel MOSFET, we should have a higher gate with respect to its source. So basically, if we have a 19 volt on the source, we should have 24 volt on the gate. So this higher voltage is driven by the charger IC here. So once the charger IC receives 19 volt on the CEM SRC pin, then the 19 volt will go into the charge pump inside the charger IC, and the charge pump will add plus 6 volt, and then it will send as 24 volt on the AC drive pin here. So in order to send this AC drive as 24 volt, the charger IC ensures that some of the requirements are met here. So for example, the AC detect pin and some of the voltages should be met here. So we can see that one on the details below. So very important is the AC detect pin. So we should have a certain voltage on this pin in order for the charger IC to send AC drive voltage as 24 volt. Okay, right. So if you go down to the pinout details, more details. Okay, so pin number 1 and pin number 2 goes for current sensing of the adapter. So on pin number 3 here we have the CM SRC, which is 19 volt. So we should check whether we have the 19 volt. And on pin number 4 here we have the AC drive voltage. So these are the requirements for the AC drive voltage to have 24 volt. So you can see the AC detect pin should be within 12.4 volt to 3.15 volt. So the AC detect pin should be within 2.4 to 3.15 volt in order for the charger IC to execute 6 volt above the CM SRC voltage. So 6 volt above the CM SRC means 19 volt plus 6, 24 volt on this pin here. So AC detect should be 2.4 and CM SRC should be 19 volt. And here we have the under voltage lockout function. So VCC voltage should be above certain limit So basically there will be 19 volt mostly, so no problem. So, and these are the important things. Okay, and on pin number 6 we should check whether the voltage is within the range of 2.4 to 3.15 as mentioned on this point here. So AC detect pin is above 0.6 volt and VCC is above UVLO and the LDO is present. So the LDO is already present in this motherboard that we saw, it was 6 volt, so there's no problem with that. So okay, so the important checkpoint is only on 3 points. So if we have 19 volt on pin number 3 and this range on pin number 6, then we should have a drive voltage. So any one of the requirement is missing. Either we may not have 19 volt or we may not have the 2.4 to 3.15 range on this AC detect pin. Okay, so now we need to go to the motherboard and check whether we have these requirements met on the charger IC. Okay, now let me connect the adapter. The adapter is connected. So we need to check on pin number 6 whether we have 2.4 to 3.15 volt. So pin number 1 is on this side. So here we have the dot here. So pin number 1, 2, 3, 4, 5, 6 is on this side here. So straight away from this resistor here. Okay, let me check the voltage. So on this pin, okay, if you look at the voltage, here we have 1.3 volt. So the range should be within 2.4 to 3.15 volt. So 1.3 is not appropriate. So if we have 1.3 on pin number 6, then the charger IC will sense that the adapter is not valid and it will not send the AC drive voltage as 25 volt as in the AC drive pin. So this is the problem here. So we need to check. So it looks like a resistor divider here. So here we have another resistor here. So what about this one? 1.3 on this side. Yes, here we have 19.45 volts. So this is directly from the adapter. The voltage comes from the adapter 19.45. Then it got divided as 1.3. So this should be the ground. Yes, so this is ground. Okay. So let me clarify it more clearly. Yes. So this is just a resistor divider circuit. So on this side, it is connected to the adapter directly. And on this point here, we will get the divided voltage. And on this side here, it is connected to ground. So we should have an appropriate value of resistance on these resistors in order to get an appropriate value on pin number 6 within 2.4 to 3.15 volt. But we don't have that voltage within this range because either this resistor or this resistor increased its value in resistance and the divided voltage has been dropped to 1.3. So what we have to do now, we have to replace either one of these resistors in order to bring the voltage within 2.4 to 3.15 volt. Okay, so we can do that by making a calculation with the resistor and the voltage. So, and after that we can replace an appropriate resistor on this place here. Okay, now let me measure the value of the resistor actually in this motherboard. Okay, so let me check that one. So the resistor that is connected to 19 volt, the first resistor is having 19.2 kilo ohms. Okay, and the resistor connected to ground has 3.3 kilo ohms. Okay, 19.2 and 3.3 kilo ohms. Okay, so here we have the resistor divider calculator. So we can put the source voltage as 19.5 volt. So 19.2 kilo. Okay. and the output voltage, okay, the resistor 2 was 3.2 kilo ohms. So if we calculate it, we can get an output voltage, and it is 2.7 volt, but on the motherboard we had 1.3 volt. Okay, so no problem. So if we wish to change the R2 resistor, the desired output voltage, so normally the voltage on the AC detect pin will be around 2.6 volt. So we can set that voltage here, and if we calculate, we can get a resistance value. So it should be 2.9 volt. Okay, so approximately the voltage is okay on the resistors, I think. So I guess there might be a problem on the charger IC maybe. So anyhow, so the resistance should be 2.9 volt, 9 kilo ohms, so that is fine. So if I wish to change it as 2.8 volt, let me see. If I calculate, we have 3.2, okay, 3.2 kilo ohms. So the voltage and the ratings are okay, I think. 19.2. So if I wish to change as 2.6 volt, and then the R1 resistance, so it should be 20 kilo ohms. Okay, so I guess the resistance value of the first and second resistors are okay. If we have 19.2 kilo ohms, we should get 2.8 volts, so which is appropriate for the charger IC as the valid adapter. I'll just try to remove this charger IC and replace a brand new one and see whether the AC detect voltage comes around 2.8 volt. Okay. Okay, so before replacing the charger IC, so we can do a trick here. So here we have the trace going into the charger IC after the resistor divider. So I'm going to cut this trace here in order to isolate this part and this part. So after cutting this trace, I can see whether we have the divided voltage on these pins here. Okay, so let me take the knife. Okay, and if I check the continuity, we should not have the continuity between the resistor and the charger IC now. So beep. Okay, yes, now we don't have any continuity. Yes, okay. So now let me connect the adapter and check the voltage on the resistor dividers now. Okay, the resistor divider. So you can see the resistors values are appropriate. Still we have 1.3 volt. So I don't know why different voltage. So the voltage should be, according to the resistor divider calculation, we should have around 2.8 volt. So anyhow, let me measure the resistance value again in the resistors. Okay, so the upper resistor, the R1 resistor, is 19.2 kilo ohms. Okay, the R2 resistor is 3.3, so the resistance value is appropriate. Okay, so what would be the problem then? So let me check whether we have a continuity from the charger IC to the resistor. Yeah, we don't have the continuity, so that is fine. So now let me replace another resistor here and get a voltage around 2.8 volt. Okay, or else I can try to resolder these resistors here. So we can do that first, and we'll just replace another resistors here. Okay, Now still we have 1.3 volt. So let me replace both of these resistors and check whether the voltage is okay. All right. So if we don't have an appropriate resistor, what can we do? We can replace two resistors from another motherboard from the same section here. So we can replace the two resistors from the ACDET line from another motherboard and replace it here. So I'm going to use that method. Okay, so I couldn't find any resistor divider in the motherboards that I have here. So I just took a random 100 kilo ohm resistor for R1 and 15 kilo ohm resistor for R2. So the R1 resistor was approximately around 98 kilo ohms. So the divided voltage of these two resistors would be 2.588. So this is appropriate. So we should have minimum about 2.4, between 2.4 to 2.15 volts. So this is above 2.4 volt. So that is okay. So I have already placed it on the motherboard, and let's check whether we have this voltage on the motherboard. Okay, so these are the two resistors that I have placed now. So this is the low resistor, the R2 resistor connected to ground, and this is connected to the main power 19 volt here. So we can check the resistance of each of the resistors here. So the low resistor here we have approximately around 14 volt here. Okay, right, 14.2. And okay, this is showing around 49. Okay, so as they are on the motherboard on its place, so it is showing a lesser ohms value, but I have checked removing these resistors just uh, away from the pads, so that was showing like 100k the R1 resistor and 15k the R2 resistor. So now they are fine. So now let me connect the adapter and check the voltage on the resistor divider. So if I check the voltage, yes, now we have 2.5 volt. So approximately okay. So 0.1 volt is higher than the expected voltage. So what we have to do now we may not have the voltage because we have now already cut the line. So we have to jumper that line together, this line here, and see whether we have the main power rail. Okay. Yes, we do have the continuity. Okay, fine. So now let me clean it. No, we don't have it. Yeah, okay. Yes, we do have. Okay, now let me connect the adapter. So I'll just turn on the DC power supply as well. Okay, now the power supply is visible to you now. Let me connect the adapter. Yes, and the adapter is connected. Now you can see the amperes drawing around 5 milliamps. Okay, now let me see whether we have a main power rail. So, okay. Yes, we do have the main power rail. So 19.45 volt is present. And if I check the voltage on the gate of the MOSFET, now we are having 24.5 volt and everything is okay. And if I check the voltage on the resistor divider of the ACDET, we still have 2.5 volt. So You can see if there is a problem on the AC detect pin, the charger IC will not send the AC drive signal to the MOSFETs here. So now the MOSFETs are switching properly and we are having the main power rail on this motherboard. Okay, so let me check whether we have any other voltages such as the standby voltages. So already you can see there's a light glowing on the edge of the motherboard. Okay, so it's a symptom that the adapter is plugged in. Okay, so here we have the standby coils. So let me check whether we have 5 volt and 3 volt. No voltage. Yeah, we have 3.4 volt and 5.1 volt. It is also present. Okay, everything looks perfect. So let me try to trigger the board and see whether the board is turning on. Okay, so I need to find a place where I can trigger the board. The power button connector. Okay, for a good measure I can place this inside the laptop, I think, just to connect the power button connector and test for whether the board is turning on. Okay, let me connect the adapter again. Alright, connected. So if I press the power button, look at the fan of the motherboard here. Yes, board has turned on. You can see it's taking around 500 milliamps and the fan is spinning and the board is working fine. Okay, I'm happy with that. So I'll just try to assemble everything inside the laptop and go for a last check. I hope everything should be working fine. Alright. Okay guys, everything is assembled inside the laptop. So now look at the display of the power supply. Now I am going to connect the adapter. Okay. Right, the adapter is connected and you can see the amperes drawing around 30 milliamps. Okay. So now let me open the laptop and press the power button. Okay. Yes, the amperes drawing around 700 milliamps and the display is executed. Okay. So everything is working fine. So thanks for watching guys. So I can tell this to my friends, so I have repaired it. So you can see the importance of the AC detect signal in releasing the voltages by the charger IC, such as the AC drive voltage for the MOSFETs. So it is very crucial to check those points and the voltage should be within 2.4 to 3.15. So anyhow, we have repaired this one. So thanks for watching guys. So stay tuned for our future updates and bye.